Okay, coming back. So here it will dissipate the energy through it. Till here, energy will get dissipated. Okay, see, this is energy dissipation. Okay, energy was at a peak at this point. From here, it will dissipate and will reach to zero here. And again, as energy is reached zero, current direction will be changed. And according to source voltage, now current will move in a positive side. Again, here energy in the inductor will get stored. Okay, when it is inductor charging and current as in having this direction. Again from here like this. So we are getting somewhat sinusoidal waveform. What we have achieved, we are getting somewhat sinusoidal waveform. Okay, so this is for a single phase half bridge inverter with resistive and with inductive we have seen. Now single phase full bridge inverter. Okay, in single phase full bridge inverter, again when the load is resistive, this black are diodes of non-use. Only two limbs with the four devices, four thyristors will be of a use. Now what will happen, see, when now I will quite rush up because you're gone with the concept, or you collected the concept, so now it will be very easy for you to understand. So see, when get pulse to the 1 and 2 thyristor, 1 and 2 pair is giving same number 1 2 and 3 4. Okay, so when 1 and 2 are having get pulses, the current will be moving from Vs through T1 through point A, load B, T2 will come back to the source. What the direction? This is the direction. Okay, so load has having A terminal positive, B terminal negative. Okay, and current is moving from A to B. So see, this is the load voltage, sorry, Vs. Okay, now what I have done, after one this particular point, okay, T by 2, I have commutated T1 and T2 and given get pulses to T3 and T4. Now what will happen, it will start conducting from T1 and T2 are off, no, so it will start from here, it will go to here. From T3, see, voltage polarity change, B1 positive, A1 negative. Okay, so B to A through T4, it will complete path like this. Try to understand. Okay, so current and voltage at a load has been changed the polarity, so we are getting negative voltage. Okay, like this. Okay, sinusoidal voltage we have got square wave. Similarly for current, the phase and shape will be same, only amplitude will be less. Okay, now one main thing is if load is inductive. Now what will happen, see, you can find by your own also. When load is inductive, when T1 and T2 are conducting, this is the path. Now, when T1 and T2 are commutated and T3 and T4 are made on, actually the current which was flowing from A to B should suddenly change from B to A, because now it should conduct from T3 like this. Okay, but as I said, load is inductive, it will oppose a sudden change in the current. So it will maintain the current from A to B only, but it will see that what is the path. T3 is reverse bias, this is off, so it will use D3. So it will go from here, or when D3 will get 0.7 volt, it will get turned on. From here, it will go like this, from against the voltage, and through D4, it will complete the path. Are you getting? So still, till inductor has stored energy, it will conduct like this. When stored energy in an inductor vanishes, obviously the source will take lead, and through T3, it will change the direction. Okay, now this is conducting from T3 B to A T4. Current polarity change, voltage was already changed. Now when again you made T3 and T4 off and T1 and T2 on, actually the direction through current should suddenly change from T1 from A to B, but it will not happen. Okay, current was flowing from B to A now, so what will happen, it will maintain B to A and it will go through D1 through Vs D2 and complete the path. Previously it was using diode D3 and D4, now it will use D1 and D4, D2, D1 and D2. It will complete the path like this till inductor has stored energy. When stored energy in the inductor get vanishes, obviously source will take lead and it will it will conduct from T1 A to B, T2 and will back. Okay, so here I have shown the diagram. When S1, T1 and T2 are conducting, this is the thing. Okay, when T1 and T2 made off and T3 and T4 made on, it suddenly it will not conduct through T3 and T4. It will maintain the direction. For that, it will use D3 and D4 like this. Okay, when inductor get discharged, it will then conduct through S3 and S4. That is T3 and T4. Okay, when T3 and T4 made off and T1 and T2 made on, so it will, to maintain the current direction, again it will conduct from diode D1 and D3. Just a minute. Just a minute. Okay, sorry for interruption. We'll start from here. Okay, so I have explained you this waveform. Now see the actual waveform. So voltage is when T1 and T2 is conducting positive, when T3 and T4 are conducting voltage negative. So voltage is square wave. The only thing is the current. Now when these are conducting, inductor get charged like this, load inductor. Now from here what will happen, actually current should have changed direction, it should have started from here now, but it will not, it will not happen because inductor has stored energy over here. Now actually what will happen, from here inductor will maintain the current in a positive direction only. Okay, means it will maintain the direction. Okay, from previously B to A, no. Okay, B to A, see here. So when T1 and T2 are conducting A to B, okay. So though T1 and T2 made off, current will move from A to B only. For that, it will use D3 and D4. Okay, see here. So current will move, but inductor will get slowly discharged. See, stored energy is dissipated. So till that this point, it will be completely discharged, and from here it will change the direction because source will take the lead. Till here it will be in a opposite direction. That time again through switches inductor get charged, and from here through diode inductor will get discharged here again. From this point, again through switches inductor will be charged, then discharged. Similarly we have get a sinusoidal, means triangular wave. Okay, somewhat I can say sinusoidal. So this is a single phase full bridge inverter. Okay, so in next lecture we will start three phase bridge inverter. Thank you.